Now, continuation for this example. Example number 2. Line L is parallel to line M and P is the transversal. Okay, it cuts the parallel lines. Okay, find the value of x. So you need to find the value of x and the degree measure of angle 2 and angle 3. So looking at this figure, we have angle 2 and angle 3. Okay, since first you need to find what is the relationship between angle 2 and angle 3. As you can see, angle 2 and angle 3 are vertical angles. And vertical angles are congruent. So when we say if they are congruent, they have the same length or degree measure. Measure of angle 2 is equal to measure of angle 3. If our measure of angle 2 has a value of x plus 17, okay, and our measure of angle 3 is 2x minus 15. So that is equal to 2x minus 15. So next, let us transpose. Okay, x transpose here, it will become 2x, or bring down 2x. From x, positive x, transpose here, it will become negative x. Now, from negative 15, I will transpose it here, then it will become 17 plus 15. From negative 15, it will become positive 15. So 17 plus 15, that is 32 degrees. So 2x minus x, that is x. So by the our value of x is 32. Okay. From 32 degrees, so we need to find degree measure of angle 2 and angle 3. So measure of angle 2 is equal to x plus 17. Since our degree measure is, or our value of x is 32, substitute x as 32. Then 7 plus 17. 32 plus 17, and that is 49 degrees. Okay, our measure of angle 2 is 49 degrees. How about measure of angle 3? Measure of angle 3 has a measure of 2x minus 15. So 2 times our x is 32, close parenthesis, then minus 15. So 2 times 32 plus, minus 15, and that is 49 degrees. So as you can see, why they are the same measurement, because they are vertical angles, and vertical angles are congruent. Okay, just remember that. Next, we have this example. Given the given figure, line M, same as previously. Let us find the value of x. Okay, let us find the value of x. So since we have measure of angle 1 and angle 7, okay, first let us identify what is the relationship between measure of angle 1 and angle 7. Okay, measure of angle 1 and angle 7 are the same side exterior angles. Exterior. Okay, so in this theorem, the same side exterior angles are supplementary. Supplementary. So when we say supplementary, if you add the measurement of angle 1 plus measurement of angle 2, and that is equal to 180 degrees. Measure of angle 1 is 4x minus 25 plus measure of angle 7 is x plus 5, and that is equal to 180 degrees. 4x, combined like terms, 4x plus x, that is 5x. Negative 25 plus 5, and that is negative 20, is equal to 180 degrees. So 5x, bring down 5x, 180 From negative 20, it will become positive 20. Then 5x is equal to 180 plus 20, that is 200. Then divide both sides by 5, and then you will get x is equal to 200 divided by 5, and that is 40. So our value of x is 40. Now, if you are asked to find the degree measure of angle 1, okay, so just substitute it, 4x minus 25. Our measurement of angle 1 is 4x minus 25. So we have 4 times 40 minus 25. So 4 times 40, then that is 160 minus 25. Then measure of angle 1 is 160 minus 25. That is 135 degrees. Okay, so let us close it. Next, how about measure of angle 7? Measure of angle 7 has the degree measure of x plus 5. So substitute, for x is 40 plus 5, and then the degree measure is 45 degrees. So measure of angle 7 is 45 degrees. So that's how we find the degree measures of angles formed by parallel lines cut by transversal. Okay. Now, let's define the perpendicular lines. Perpendicular lines also happens if a transversal line cuts a parallel lines, or cut the parallel lines, and then the angles are formed by 90 degrees. Okay. For example, let us have the definition first. Perpendicular lines are defined as two lines that intersect, form right angles. Line segments and rays can also be perpendicular. For example, we have a vertical line, and that is line F. And it intersects with a horizontal line, that is M. So by the intersection of these two lines, so we have one point, that is point P. And looking at the angles, okay, we have a perpendicular, we have a right angle. Okay, so as you can see, if you see this symbol, meaning to say that is a right angle. Okay, a right angle. And if it is a right angle, then that is equal to 90 degrees. So it follows the remaining angles are also 90 degrees. This one is also 90. This one is also 90. This also is 90 degrees. Okay. From the definition, it is not only line segments or lines. Ray and segments can also form, okay, and form a perpendicular line. Okay. So looking at this, the theorem, if the two coplanar lines are perpendicular to a third line, then they are parallel to each other. So for example, we have a line M, okay, and line N, and the third line is the transversal line. And since it cuts the parallel lines perpendicularly, okay, so all the angles are right angle. Okay, so you don't have to compute it. All the angles here are 90 degrees. 90 ito, 90, 90, 90, 90, 90. So that is a perpendicular line. So if we read this one, if M is perpendicular to N, and line L is perpendicular to line N, then line N is parallel to line L. So that's how we read symbols in geometry.